Hello, everyone. We're the FlexMetrics capstone team, and we'll be presenting our predictive analytics project to you. Before we begin, we'll start with some quick team introductions.
Hello, my name is Brendan Atkinson. I graduated from Southern Illinois University with a degree in mechanical engineering. After completion of this program, I plan to work as a design engineer for Collins Aerospace.
My name is Tyler Scott. I study computational modeling and data analytics at Virginia Tech, and upon graduation, I'll be working at EY doing technology consulting.
I'm Kayla Jones. I graduated from Virginia Tech with a psychology degree, and after graduating from this program, I'll be working as a consultant at NTT Data.
I'm Esther Wing. I graduated Virginia Tech with an undergraduate degree in business information technology, and I'll be joining FlexMetrics as data analyst.
My name is Isaac Moore. I graduated from Liberty University, studying business administration, and I'll also be joining the Flex team after I graduate.
We would like to give a big thank you to our capstone sponsors at FlexMetrics, especially Janet, Callan, and Don for all of the help they've provided us throughout this project. We'd also like to give a big thank you to our faculty advisor, Dr. Fraticelli, for all of the help that she's provided us as well. Our problem statement is, how can FlexMetrics develop and deliver a method for predicting machine failures to its diverse client base in a way that's clear and actionable? To give some background, providing real-time, accurate tracking of manufacturing outputs ensures that manufacturers can maintain oversight over their production processes. FlexMetrics seeks to make life as easy as possible for manufacturers. They've helped do this so far through integrating software into machines to gather data on different metrics that these manufacturing companies can then use to make more informed business decisions. They've asked us to take on the next step by finding a way to implement predictive analytics to be able to prevent catastrophic machine downtime events from happening before they do. That being said, this introduces our project. I'll now pass it off to Esther to talk about project objectives.
Thank you, Kayla. So we began our initial analysis in September of 2023, which included most of our time researching our different methodologies to finalize our final solution. And in December of 2023, we started the data transformation process, which we worked really hard on to help us start off this project with the data that we had. Then we started developing our machine learning model in February of 2024 and initialized our dashboard in April of 2024. And in May, we finalized our recommendation. Our goal of this capstone was to help FlexMetrics integrate predictive analytics power into their current software. And the first part was the machine learning model development. As I said, we spent a lot of time working on the data transformation process, then also on fitting the model and testing the machine learning model. Next part was dashboard development, which we spent a lot of time on integrating the model results into our dashboard, because we wanted this to be helpful to FlexMetrics clients in their daily shifts and their daily workflows. So this process was very important to help us to be able to develop the actionable insights using our visualizations and to help them understand what is happening. For our data transformation process, we began with formatting the data frame. We had a lot of data from our sponsor, FlexMetrics, and we had to use this data and to determine which metrics were actually significant to our model. We talked to expertise about it. We also talked to our sponsors, and we developed calculated variables, calculated metrics that would fit into our model, which I'll now pass it off to Tyler to explain more about our final data frame.
Thank you, Esther. This leads us to our final data frame, which consisted of 26 different unique metrics over the previous 5 shifts of data, which leads to a total of 130 variables. Now, we chose the previous 5 shifts of data because any figure beyond this 5 amount did not add to the predictive power of our model, so we chose to only include the previous 5 shifts to predict the upcoming shift and whether there would be a catastrophic failure or not. Next, we looked at which algorithm we were actually going to choose. Now we chose or tested multiple different types of algorithms, neural networks, random forest as you see on the screen, and different curations within these, and we ultimately landed on the random forest algorithm. Now what this is an assortment of unique decision trees that each uniquely predict the target outcome. And then of these decision trees, whichever prediction is the most prevalent is the overall model prediction. So for example, if I have a model with 10 decision trees and 7 predicted a catastrophic failure and 3 predicted no failure, then the overall model would predict a catastrophic failure. Now, to actually evaluate our model performance, we use a confusion matrix to classify results. And we focused on 2 specific metrics. The first of which was our false flag rate. which you can see on the screen with our confusion matrix, is calculated by taking 7 divided by 72 plus 7, which gives us our 8.86 false flag rate. Now, what this is actually measuring is of the days that there was no catastrophic failure, how many days did we inaccurately say that there would be failure? We wanted to minimize this as much as possible when talking with our sponsor, because if managers were told that there's an issue with their machine and they go try and fix it and there's actually nothing wrong, it would decrease engagement with the tool and they would be more likely to completely disregard using the tool. And so we wanted to minimize the occurrence of this while maybe potentially missing other predictions of failure. The next metric that we wanted to optimize is our true positive rate. Now, this is of the times that we predicted there was a catastrophic failure, how many days or shifts was there actually catastrophic failure? Now on the screen, the 72% metric is calculated by taking 18 divided by 18 plus 7, which gives us 72%. Now we want to focus on optimizing this metric as much as possible because this is where the real value of our deliverable comes from, is being able to predict when a machine is going to have significant amounts of downtime. This is where large losses of money, large amounts of stress, and a bunch of different issues occur. And so with these two metrics, true positive rate and our false flag rate, optimizing both, we are comfortable with our results along with talking with our sponsor, and they're comfortable with how the model is performing. And so we moved on to the pipeline stage, which I'll now pass off to Isaac to discuss further.
Thank you, Tyler. So we took this Python code and we directly connected it to a SQL database. From here, we could set up a task manager auto refresh. So before every single shift, Flex has the most recent data, therefore making it the most accurate prediction that we could give them. From there, it's just a direct Power BI data flow connection. Every morning, they'll get a Power BI report that shows them the most recent data with our most recent predictions. So this will be the actual Power BI report that we want the managers to see first thing the day before they start their shift. We want this top table to be the main focus. So here we'll have the area, the equipment, and then its respective risk level, and a top predictor of why our algorithm thinks that machine will go down for the day. So the risk level is split up between low risk, medium risk, and high risk. These will be color coded with green, yellow, and red. Low risk is anything from 0 to 50, medium is anything from 50 to 80%, and then a high risk is anything above 80%. For the manager who wants a little more detail, he can put his mouse right over the risk level and it'll show the exact percentage of what our algorithm thinks that machine is going to go down for the day. Then below we'll have like an area portfolio. This will be somewhat of a filter. If you want to click through to the specific area or the specific risk level, it'll limit that table above and it's easier to scroll through and see what's actually going to go down for the day. On the next page, we have a drill through page. This will show the equipment name, its risk level, who's working on the machine for that day, and the job ID. Under that, we'll have 3 predictors for our algorithm. It might give them a little insight as to why that machine could go down for the day. Below that, we have a failure rate trend. This will show the last 5 shifts and what our algorithm has predicted for those 5 shifts. If we see a trend line go up, that might be a little more of an indicator for the operator that today might be the day that we get a big catastrophic failure. We need to check something out. Once we figure that out, there's a D1 Pareto that will show reason codes for why that machine has been going down recently. But in the table below, it'll show that reason code, how many times it happened, the average amount of times it happened, and the duration that it happened. And it'll show the operator that was working that machine for the day. For the manager who's looking, they might have a little insight as to what it's been going down with or what's been going on with that machine recently, and maybe get a little more insight as to why the machine could be going down for the day. So now I'll pass it off to Brendan to talk about key benefits.
Thank you, Isaac. So we have several major benefits that we like to highlight with the result of this project. The first one is that we have increased the product value for FlexMetrics. And what we mean by that is that not only have we added value for the FlexMetrics brand itself, but we've also added value to the clients who use their product as well. So, like said before, unexpected downtime is very costly for a manufacturer to deal with. And so instead of reacting to downtime when it occurs, we are now able to be proactive and catch it likely before it occurs, or at least mitigate it before it becomes too costly. Our next key benefit is that we've increased the user engagement all around with this software. And so we have supervisors and managers who have more of an incentive to use the FlexMetrics OS than they previously had. And for the operators, they have more of an incentive to input quality data into their system whenever something does occur. Our last key benefit is that we have introduced FlexMetrics to the world of predictive analytics. You can see this as like the next big step from data monitoring to data making predictions. And so with this, we're able to bolster the FlexMetrics brand and provide them with plenty of opportunity moving forward to create more predictive analytics products. In addition to this, we have two new employees for FlexMetrics that were from this team. They gained two great new employees who have worked on this project since the inception. And so moving forward, they will be leading the charge on any sort of new project or new product that FlexMetrics wants to put forward in the predictive analytics space. And lastly, we have our final comments, our takeaway from this. We think that it's an excellent thing that we have been able to use what we've learned in our classes to develop this project and actually put it towards good use in a practical, real world setting. And so for that, we're quite thankful. And with that, this concludes our presentation. I'd like to thank the CBA staff, our faculty advisor, and the FlexMetrics team for all of their support whenever developing this project. And at this time, I'd like to open it up for questions.
Going back to your confusion matrix, I know you touched on this a little bit. I'm just a little curious kind of what went into the trade-off between trying to minimize like the false flag rate versus, I noticed there's a fair amount of instances where you predicted a negative for catastrophic failure, but there actually was a positive catastrophic failure.
Yeah.
And what was kind of went into the trade-off between those?
Yeah, so that was talking with our sponsor, and Flex currently has not necessarily an issue, but there are some people engaged with the Flex software in the manufacturing world where it moves very slowly and they like paper and pencil and very outdated methods. And so when you introduce new software, you want to cater it to what's going to get them to actually engage with it as much as possible. And so we felt that if we had those errors of a false flag, it was much more likely for them to just completely disregard the tool. So that's something we've talked about in the future, where if that engagement increases and they're actually using our tool, then we could manipulate our model to then catch more of those positive days that we're missing, and then that would naturally induce more false flags as well.
How do you foresee the skills of this project to eventually translate to your career?
So two of us are working at Flex. And with Don, our sponsor here, and also Jay, the CEO of the Flex team here today, I would like to say that we've learned a lot on project management and how to work on something that you don't know how to do right now. I know for some smaller startup tech companies, there are a lot of different hats that we both have to wear, and we're both very thankful on the different problems and roadblocks we've encountered during this capstone project. And it helped us understand what it is like to not be able to do something at this moment, at this time. You're not just gonna handed a project by your teachers, your professors, and telling you A, B, C, this is what you need to do, and it'll get done. There were a lot more going on behind the scenes than what we've talked about. And we're very thankful for everything that we have learned. And actually, we've learned a lot from Dr. Sharp's and Dr. Fashli's classes that we actually inputted and used during our project. So, yeah.
Go ahead. So I'll tie into what you were saying. You guys are all gonna go out into the work world, and a lot of your bosses, particularly if you're in the consulting world, are gonna say, go get us more work. Right? There's a soft side to that, and that's the customer relationship skills that this project really enhances. Now, it's relatively easy when you're dealing with a good guy like Don Robb and Jay Foster. I do a handshake deal with those guys. Those of you that understand the business world, that's a very high compliment. So what I would ask you to think about, all of you in this room, yes, you're being hired largely for your technical skills right now. But as you move up the chain, I'm not gonna say that's less important. You're gonna have to start using other skills. So think about that. That's a real compliment to you two that these folks hired.
And since we have these folks here, I wonder if you have anything to share from the sponsor side.
Well, this team was phenomenal. We threw a lot at them with any project like this. I'm sure every team in here could say what their biggest challenge is, what the heck are we supposed to do? I mean, how do we scope this thing? And they just did a phenomenal job of taking, you know, our suggestions, all the data, and coming up with the methodology. They had an unfair advantage because they did an internship with us last summer, actually spent time at some customer sites to really start to get a feel for what this product is, and more than anything, began to understand how what they were going to do impacts. You go into everything that you buy is produced in a manufacturing facility somewhere, and to see what really happens in the world of manufacturing, I think was incredibly valuable to them. But look, it's just a case where I think we had a pretty well scoped project, a phenomenal team. The Callan, who is not here, Callan Garst, was just a great mentor to them. And it just clicked, and we have a new product feature in our product suite. So it's a great win-win. And we got two new great features.